Welcome to the first video of Module 6. So the topics of Module 6 are given as shown. So our topic is software quality assurance, okay? And we'll be discussing background issues, elements of software quality assurance or SQA in short, then SQA tasks, goals and metrics, formal approaches to SQA in this video, okay? Now, define the term software quality assurance. It is a KTA question. So, it is the quality management activity. Okay, it is an umbrella activity that is seen or applied throughout the software process. Okay, then it encompasses the software engineering technology methods and tools, and it has quality control tasks including formal technical reviews which are applied throughout the software process. It is a multi-tiered strategy. Then there is documentation, okay, and any change, as we have discussed in module 5, changes and all should follow the SCM, okay. So if there is any change, so our region is software quality assurance, how the quality is assured, okay. Then so the control of software documentation and the changes made to it, then a procedure to ensure the compliance with the standards. So whether a product is complying with the standard, okay, is all a checking which is done by the quality assurance team, SQA team. Then it involves measurement and reporting mechanisms. Now, what are the background issues? Now, mainly the constituencies or the people who are concerned with the software quality responsibility are software engineers, project managers, customers, salespeople, and the individuals who serve within the SQA group. Okay, so they got to see that the software is according to the customer's point of view. So that is all working in the background. Now, the elements of the software quality assurance, it is a KTU question. So mainly it is the standard, okay. So the IEEE ISO standards are there, and the job of the SQA is to ensure that the standards have been adopted. Whatever standards that are adopted are followed, okay, in all the work products, okay. Then next is reviews and audit are an inevitable element. So the SQA personnel has to perform audits, okay, and it ensures that the quality guidelines are being followed in the software engineering work, okay. Next is testing. Okay, testing is again a quality control function to find the errors. So the job of the SQA is to ensure that the testing is properly planned and efficiently conducted. Okay, next is the error collection or analysis. Okay, so the SQA collects and analyzes errors and defects and how they were introduced and how or what activities are best suited to eliminate them. So all these kinds of things are concerned in SQA. Next, change management. SQA ensures that adequate change management, that is SCM, software configuration management practices have been instituted. Then education. So education to the software engineers, their managers, the stakeholders will improve definitely the software engineering practices. If you educate the people around you, the product will be better actually. So the SQA organization takes the lead in software process improvement, okay, by this education. Next, vendor management. That is the job of the SQA organization is to ensure high quality software results by suggesting specific quality practices that the vendors, whoever it is who are their vendors, they should have specific quality practices. So that is done by vendor management in the SQA. Next, security management. SQA ensures that appropriate process and technology are used to achieve software security. And safety, of course, SQA must be responsible for assessing the impact of software failure and the steps to reduce the risk. Then risk management, of course, SQA has to manage the risk and all the risk management activities SQA ensures whether it is properly conducted, and the contingency plans are being carried out. So the next is SQA tasks, or it could be the role of an SQA group. So we come across SCI, which is the Software Engineering Institute, which recommends a set of SQA actions or the tasks, okay, that addresses SQA planning, all those activities. Okay, so what are the tasks mainly? First is to prepare an SQA plan for the project. Okay, that is, the plan will identify the evaluations to be performed, the audits and the reviews to be conducted, the standards that are applicable to the project, etc. Next, participates in the development of the project process description. So the SQA group reviews the process description in order to check the compliance with the organization's policy. Then whether the internal software standards are complied with, external standards are complied with, and other parts of the plan, is it moving according to the plan. So this is another task of SQA. Next is it reviews software engineering activities to verify compliance with the defined processes. Then audits designated software work products to verify compliance with those defined as part of the process. That means at the lower level, that is part by part, you take and do the auditing whether it is in compliance with the standards. Okay, so just go through it. Next, the task is to ensure that deviations in the software work and work products are documented and handled according to some documented procedure. Okay, then it records any non-compliance and reports to the senior management. So all this has to work in a flow for the product to be of a quality one. Okay, the next is goal, attributes and metrics of SQA. So they could also ask the question as goals of SQA. So first of all, we'll discuss the goal part of it. Okay, so it has to achieve a set of goals. First is requirement quality. Okay, correctness, completeness and consistency of the requirement model will have strong influence on the quality of all workflow or work products that follow. So if the requirement model is completely correct and consistent, the quality of the work products that come out of it would be very good. Okay, so SQA must ensure that the team has properly reviewed the requirements model to achieve high level quality. Next is design quality. So every element of the design model should be assessed by the team to ensure that it exhibits high quality. Okay, whether the design itself conforms to requirements. So design quality is another goal of SQA. Then code quality. So the source code and the related work products must conform to the local coding standards. Okay, so that is another code quality. Okay, then quality control effectiveness. That is, a software team should apply limited resources in a way that has the likelihood of achieving high quality result. So it is a challenge actually. With the limited resources that are available, they should get the highest quality possible. Okay, so this is possible only by our quality control effectiveness method. Okay, the SQA would analyze the allocation of resources for reviews, test or assess whether the resources are being allocated in the most efficient manner. Okay, so these are the goals. Okay, four goals are there. The goals of SQA: to have quality. Okay, what are qualities? Requirement quality, design quality, then code quality, and the general quality control effectiveness, because the resources are limited. Now next is the attribute. Okay, and then the metrics. Okay, so the main question is what are the goal, attribute and metrics. So we so far discussed the four main goals, as you can see here, four main goals, and corresponding to each goal there are some attributes pertaining to that goal, and the metric or the unit in which that would be expressed, that attribute would be expressed, that is given on the other side. Okay, for example, in requirement quality, you have the attributes ambiguity, traceability, model clarity, and ambiguity is concerned with the number of ambiguous modifiers. Okay, that would be the metric used in ambiguity attribute. Like that, please follow the others. Next is formal approaches to SQA. So formal means using some mathematical expression. How do you go about this SQA? Computer program is a mathematical object, rigorous or exact. Okay, rigorous means exact syntax, that is the mathematical formula also, and semantics. Syntax and semantics can be defined for every programming language, and a rigorous approach to the specification of the software requirements is available. So for every programming language, you can have a syntax and semantics, and for every requirement there can be a rigorous approach. Okay, a formula based approach for that. So if the requirement model and the programming language can be represented in a rigorous manner, it should be possible to apply the mathematical proof of correctness to demonstrate that the program conforms to the specification. So we need to say here that once we have established, once we have a mathematical derivation, okay, we can show that or we can apply a mathematical proof of correctness to show that our requirement has conformed to its, or our product has conformed to its requirement specification. Okay, so the next topic I will continue in the next video. Thank you.